In this video, you will learn how the Hyperloop stays alive during its travel and how it knows what to do. You will see how we get the power to use our vehicle, where all this power goes, and how we use software to command the pod. So, in essence, first we will see where we draw our power from, and then we will look at where we send this acquired power. Also, you will get an insight in some software architecture and challenges that come with the Hyperloop software. So to start off, let's see about the origin of our power. Basically, we have two options. We either store the required energy on board, or we supply it from outside. As you can imagine, both have their own pros and cons. When we store the power on board, this means we would require batteries to store this energy. And since we are traveling over long distances, this means that we need to find very big and expensive batteries, also leading to a higher weight and thus higher required power. Thus, we would end up with a snowball effect. Another option is providing our power from an external source, especially when we propel ourselves through coils that generate a magnetic field and are integrated in the tube. We open up this possibility. We can provide them with power through many external energy sources, such as, for example, solar panels on top of the infrastructure, or just connecting directly to the grid. In this way, we only require small batteries inside the pod to power the computers and lighting, which both are much smaller than the propulsive power. Now we know where to get our power, we need to see where to send it. Normally, for a system, you would create a block diagram showing all the energy flows throughout the system. We will not look at one in detail here, but rather describe it more generally. We can quickly see that any active subsystem would require power, ranging from the onboard computers to the lighting, to the information displays, to the battery management system. So, if these are all given, we get our required power for the system. Instead of simply accepting this, we can also start looking at ways to save power, and thus decrease the size and stress on our power subsystem. The easiest way to do this is to try to replace all active systems with passive ones. Here you can think of passive magnets instead of active, since the latter require a lot of power. But on the other way is to use mechanical actuators, similar to how aircraft rudders used to move by ropes or cables going through the fuselage, instead of electronically. Of course, using ropes is not the option we look for in modern applications, but smart use of levers and cogs might already offer us interesting solutions. Finally, let's have a look at the software behind the Hyperloop. The main part of this software just takes some development time, as we are also able to fly airplanes and even spacecraft autonomously. More interesting for us are the problems specific to the Hyperloop that you won't see in other applications. The main issue for us lies in the navigation, which is the part of our system that tells us where we are exactly. Since we are in a closed environment and traveling at very high speeds, we need to find a way to accurately determine where we are. If we don't and have an error of a few meters, this means that we might just stand still only after we reach the station, and passengers can't get out. One way of increasing our accuracy is by placing waypoints in our tubes. This could simply be a light that a sensor can spot when traveling at high speeds. From this navigation data, we can thus determine where the pod is located and what our speed is. This then ensures that we know how much power needs to be sent to the propulsion and when it is time to brake. Such, we can optimize our travel scheme so that we use our energy in the most efficient way, because we only brake when it's necessary and don't have to slow down early. So today, we have shortly discussed about the power and navigation of the Hyperloop pod. We see that we basically have two options for power sources and want to try to minimize this power usage. Lastly, we saw one of our main challenges in the design of the Hyperloop software.